Hello everyone, welcome to our presentation on MisMath, Mining Misconceptions in Mathematics Using LLMs. I am Mehvish Khan and I'm here with Disha Bhatt, Sneha Naik and Priyanka Amrute. I would like to thank our mentors Mr. Ajinkya Valanju and Mrs. Pooja Wakhare for their constant support and guidance. So what's the problem we are solving? In multiple choice math tests, it's not just about picking the right answer. What really matters is understanding why a student chose the wrong one. But for teachers, figuring out those mistakes for every student can take a lot of time. MisMath helps with that. You give our system a question with four options. It figures out the correct answer and also explains why each wrong answer was picked, basically showing what kind of a mistake or a misconception led to it. Key features and benefits. Our tool provides three core benefits. First, chain of thought explanations that walk students through each misstep. Second, targeted feedback pinpointing that exact misconception. And time savings for educators by automating error diagnosis and reporting. To train our system, we used three main sources. MathQA, which has math and physics questions with explanations. ED dataset, which contains real student mistakes linked to common misconceptions, and synthetic DeepSeek data, where distractors were generated along with possible reasons. For a RAG pipeline, we have added grade 6 to 10 textbooks, so our system gives explanation that match what students actually study in school. Here's a look at how MisMath works. For each topic, we show a question and how our tool explains the mistakes for each wrong answer. Each explanation is tied to a real misunderstanding students often have. We fine-tuned three large language models to generate these explanations. GPT-2, Mistral AI, which is a powerful open source model, and Llama from Meta, which is a great at reasoning. LLM fine-tuning. We evaluated on both MathQA and the misconceptions data with BERT score, where a Llama model led with F1 scores of 0.828 and 0.834 respectively, followed closely by Mistral and GPT-2. Our co-LLM pipeline chains two fine-tuned models in sequence. The first model frames the question and options, and second refines the generated misconception. This collaborative setup aims to improve generation precision by splitting the task into framing and elaboration stages. Uh, the table compares our fine-tuned Mistral and Llama bases against Falcon as a secondary model. With Mistral as the base, Falcon improved precision by 0.0437, recall by 0.0632, and F1 by 0.0524. Using Llama as the base, Falcon delivered 0.1499 precision, 0.0425 recall, and 0.1032 F1 gains, demonstrating that co-LLM chaining boosts performance over single models. To ground our answers in real textbooks, we implemented a retrieval augmented generation pipeline. It works in following three steps. Step 1, chunk and embed. We split textbooks into overlapping chunks and embed them with a mini LLM. FAISS indexing. These embeddings live in a FAISS index for fast similarity search. When a user inputs a question, the model search for most relevant textbook chunks and use those to generate a grounded explanation. We have built a web app for a RAG pipeline where teachers or students can paste the question and the system shows the correct answer, explanations for each wrong answer, and what misconception led to it, all based on real textbooks. So as you can see, the user can input question and there are and the user can give four options, and there's an option where the student can select whatever answer, and once the user clicks on get answer, so our model gives the correct answer, explanation, and what misconception. If the answer is wrong, then it will tell what misconception led. As you can see, so there's the explanation and the misconception the student must be having. So our RAG approach evaluated with bird score. It achieved an F1 of 0.813 using Mistral and 0.821 with DeepSeek augmented retrieval, confirming the value of curriculum aligned context in reducing hallucination and improving accuracy. To sum it up, by combining fine-tuned LLMs, co-LLM training, and RAG, MisMath automates and enhances the discovery of mathematical misconceptions. It uses smart language models and textbook data to understand student mistakes in math MCQs and explains where students went wrong and helps teachers